Hello, and welcome back to From the Depths. Today I bring you what you all have been waiting for, the ultimate, the incredible, three-dimensional Cram Tetris. Upwards, outwards, down, and right. What have we all been searching for in our lives? Efficiency. Pure efficiency. And what am I going to bring? Efficiency. Part 2. Welcome to Part 2. What I will be doing in this video is I will be detailing my method of building an efficient three-dimensional Tetris for cram cannons, as well as showing off my math skills, and as ending it off with building my 3D design inside turret spaces for crams, and sort of explaining what I've been doing. So here I have a test platform. On the left, I've already built a 5-layer tall two-dimensional crams, which we'll be editing to make more efficient as a comparison to the three-dimensional crams. And then I just have these pre-made layers in the turret spaces. But first, let's see how good I am at my maths. Okay, so what I've done over here is I've taken the two-dimensional slices out of my infinite layer that I've sort of described in my previous video very quickly. This is the most efficient way to stack the most efficient pattern to lay explosive pellets down in a two-dimensional plane, having 4 connections on every side. So, pulling out certain odd side length dimension squares, like 3x3, 5x5, 7x7, we can go through and calculate the efficiency of these layers and then select which one we want to use, depending if we want to go efficiency or firepower. Generally, efficiency is going to get you all the way there. So, 3x3. For a 3x3, we have 4 patterns we could pull out. 2 of these are viable for my 3-dimensional Cram Tetris design, and 2 are not. So of the 2 that are, this pattern here with the cram connector in the center and this one at the edges, we can see for the design where the cram connector is on the edges, we have 3 pellets total, 18 faces in the entire volumes, because there's 6 faces per pellet, 8 connections inside this 3x3x1, which means we end up with about a 44.4% efficiency total. So this is the efficiency of this section of Cram Pie. Now with the other design, we have 4 pellets, 24 faces total, 8 connections, we have 33.3% efficiency. Therefore, for a 3x3 design, we will choose this one. Now I go through and calculate this for a 5, a 7, and 9. And then for this chunk here of 21x21, and then all the way to a 41x41. So of the 5x5 patterns, out of the 3 that you can pull out, there might be a 4th. Out of the 3 that I could pull out that work, this is the most efficient, reaching 58.3% efficiency, meaning 58.3% of the faces that you could possibly connect to have been connected to. For a 7x7 design, out of the 3 possible patterns that you can pull out, 2 of these are the same efficiency. So have the same amount of faces, same amount of connections. One is slightly better than the other, and luckily it's the mirrorable design. Wow. For a 9x9, we get to about 62% efficiency, and this is the best design for a 9x9. And then for 21x21, we get to 64.2, and for 41x41, we get to 65.5. So you see the efficiency sort of starts plateauing, the improvement. And all this sort of section is that the larger your cram turret, the more efficient you're going to get. And then at a certain point, the efficiency increase over going larger kind of decreases. So then you have to sort of decide, do I want one massive cram turret or like a bunch of smaller ones? Okay, on to the next part of the video. So now I will be showing off my 3D Cram Tetris design. And after going online and going through all these different ones and sort of building my own, I have a few methods that I sort of figured out. This one by far is the best out of all of them, and how efficient it is for the volume. Let's get into it. So we'll go up the sizes of turrets, and I might go all the way to the 13 or even the 17x17 at the back, but it's not particularly necessary. I'll just sort of show how I do it. So first off, we're going to be doing a 3x3 turret, and how my design works is you take the most efficient two-dimensional layer and you work off that. You connect that upwards into another two-dimensional layer. So it's only a 2 high, so the pattern repeats every 2 blocks, and that makes it kind of nice. So we'll go over here, and I was doing stuff before I loaded up the save, so this is quite large. Again, pressing every wrong button. So we'll copy a layer out of this. All these, this is a 2D stack, so all these are exactly identical. We'll paste it onto here, and now we will begin building. So how it sort of works is at every connector, in a certain sort of direction, what you do is you cover the connector and the packer next to it. So if this was, say, if this connector was in the center here, you would be doing a 3. But that you'll see that in the 5x5. And then what I do with is you... Oh my goodness, I just had a stroke. Then what you do is you place payload packers connecting upwards through the layer. So what this will do is it'll connect to the top and bottom of the pellet that is directly below it when you copy it. And we'll see that in a bit. And then for the empty spaces inside the turret, you fill it with payload compactors, and if there are no connections from payload packers, with gauge increases. And I will show that off later. So let's copy this up. That was it. By the way, that was it. For a 3x3, that was my design. Just like so. Right. So for a 3x3x5 volume, our cram firing piece has 36 pellets packed into it. And then for a 2D design, we have 40. So, pretty close. Interesting. Now we will work on the efficiency of the design. So we see we're currently sitting at 384 for the 3x3 and at 554 for the 3x3 but two-dimensionally stacked. So that's quite a big difference. And we'll go through and we'll increase the efficiency of this one and the other one, and we'll see the difference. So we're currently at 384, 367, 364. Wow, that was not a lot of difference. Oh my goodness. Wow, that was pretty quick. 364.4. Now we will add payload compactors to the corners. Every wrong button. 358. 392. So that is about as efficient as it's going to get. Let's see if we add more gauge increases, whether that'll increase the efficiency. Nope. Right. So there we go. That is for the 3D design, and here we will do it for the 2D design. So 505, 501, 498. I don't really want to go any higher, but oh well. 496. Wow, this is really dropping. 496. Alright, so that's pretty much as efficient as this design is going to get. We'll just move the cram firing piece upwards into the top of this area. Actually, 497.6, 497.5. So that's pretty much as efficient as that's going to get. Now we will add the payload compactors. Like so. 466.6, 460, 459.9. That is no difference, so we will stay with this. So, after increasing the efficiency of these two cannons to almost the maximum amount, we can see the normal design that with the 2D stacking gets us to a firepower of 5.4 and a material cost of 255 and a total material per firepower of 460. Whereas the 3-dimensional design gets us to a firepower of 5.75, which is better by a little bit, and a material efficiency of 358. There we go. What a nice design. Oh my goodness, I don't know if you just heard that, but a guy just screamed in there. Okay, now we will go to a 5x5. This is it is a very simple design. I hope I'm not going too fast. So we will paste down the most efficient two-dimensional layer that we can get out of a 5x5 space. then we will mirror it, because this is a mirrorable design. And all you do is you place one connector on the one below it, and you go in this direction. You move inwards, sort of a thing, and you place it on the payload packer. And then if you have a connector in the center like this, you simply pull it out like so. And you'll end up with a pattern that looks pretty similar to this, and it just sort of extends on the larger cram cannons. So what you do here is you'll get a ton of areas like this, where you have sort of like a T intersection. And you'll place one payload packer pointing into it, and then two, as well as two others from the left and right. And you can do this from the other direction of the cram cannon thing as well. And so you still have explosive pellets on the corners. And what we're doing is every explosive pellet in this, of the two-dimensional slice, we're connecting upwards. This means that, at least for the explosive pellets in the center of the design, they will have 6 connections on every side. I should have showed that with the 3x3. So I have explosive pellets on the inside of this design with 6 connections. Let's not look at the edges, but for the ones in the very center, they have 6 connections. And that makes it a very efficient design, meaning very little is wasted. At the smallest amount being 3 connected to the explosive pellets. No connections that are below 3. So what we do with the remaining space is we add these payload compactors into the center of these T intersections, and we have spaces that we can't fill with anything. We'll just add gauge increases, because we know we'll need them later on. Right, now, simply copying this design, like so, upwards. I'm just going to a level of 5, because a lot of the designs online have that, and it just makes it easy. Plus, the efficiency goes up way higher when you get to 5 levels. Don't ask me why. Right. Adding a cram firing piece. Instantly we can see, just because of the gauge increases we placed in the inherent design of this turret, we're already at 1,200 millimeters. So just building the turret, we're at 380 material per firepower. How wonderful. And we have 116 pellets total. In the two-dimensional design, we have 140 pellets. So it is quite stronger, but let's go now and increase the efficiency. So we'll start off with the 3-dimension, with the, actually I'll start off with I'll do the 2-dimensional one. The 2D stacked Tetris, just so that we can see a massive increase. So we went from 775 to 626, and now we are at 576. Let's see if we can get it any lower. 561, 551, and if I add 2 more, we are at 2,000. So that, just with gauge increases, you get down to 546 material per firepower. Let's see what we can get it down using payload compactors. 434, that's pretty good. Oh, we can mirror this, nice. So we're at 434, 401, 392, added 2 more, 383, let's see if it gets much lower. 382, okay, that's no difference, so we'll just leave those out. There we go. 95 pellets, almost 18 firepower with a reload time of 40 seconds. How nice. Let's edit the 3-dimensional design. Let's see how low we can get this. So we start at a firepower of 380. So we'll see how low we can get that to. 356, almost a drop of 30, 346, 344, 345. Okay, so we've actually gone up. Oh, but that's because I added it over the amount. Lol. We already get 343.8. So just adding gauge increases gets us to 343. Now we will add payload packers to the remaining pellets. This pellet right here has 5 connections, so we'll replace the lower connection, the pellets with the fewer connections first, just to see what that does. 334. That was a nice increase. 327. And then we'll get to the center here. 319, and if this doesn't, 315, that's okay. What's our reload time? 38.61. We'll replace 1 more. 315. Alright, so now we are at a similar reload time, a little more. What's our firepower? 16.62 versus 17.79. It's a little less, but it's pretty much the same. 88 pellets being packed. The amount of pellets packed into a shell is pretty much dead on the same for the 2-dimensional versus the 3-dimensional design. The damage is pretty much the same, and the reload is a difference of 2 seconds. That's not too much, but what's the real value we're looking for? What's the material difference? So for a 2-dimensional cram cannon, we're sitting at 6,800 materials. For the 3-dimensional Tetris, 5,200. 1,500, 600 material difference. That's pretty nice. That's very nice. And we can see the total material efficiency is down at 315.5. This is a nice cram turret. This is what we've been looking for. And it's right here. I hope I'm being clear. Let's move on to a 7x7 design. Oops. So... we copy the best, most efficient layer. And we can mirror this design. Let me show you. Again, it is pasting it into the center and outwards. And if you have... so when it's on the edges like this, you don't... obviously, you don't send it out. But on each cram connector, you want to place 3 other cram connectors centered on it. And for the edges, you'll just end up with 2. Nice. So let's go through and connect this thing up. We have a T intersection here in the center. We have a odd little bit on the side here. So we'll just... you just want to connect these explosive pellets inwards. And you want to connect as many payload packers together. Like so. Right, and then we have one more little thing on the edge. Okay, so now we can fill the internal areas with payload packers, like so. And the remaining spaces we can fill with gauge increases. There we go. Using making a very efficient design. Extending it up. We can stack it up, delete the topmost layer, so we get down to 5. And then we will build inwards. Like this. Like this. There we are. Okay. So before we've added any efficiency to this design whatsoever, we're sitting at 248 pellets versus 300 for the 2-dimensional design. What is our material efficiency? 388 versus the 2-dimensional design, which is at almost 1300. Wow, that is quite a big difference. Let us make the 2-dimensional design more efficient. The 7x7. So we are currently at... oh, we had to boost the 5x5 all the way to 2000 millimeters. So I can say comfortably we could probably just do that with the 7x7. So just taking it to 2000 millimeters gauge, we already dropped the efficiency to 800. We increased the efficiency. We're dropping the material per firepower, but we're increasing the efficiency, so I'm getting that mixed up. Okay, now we're going to replace the explosive pellets with payload compactors. All the way down to 480 from 800. That was pretty good. 441, 427, 415. Wow, this is going pretty well. 398, 391, 386, 382, and I think that might be the last one, 378. That was a change of 4. 375. What is the reload time? It's 34 seconds. I don't want to go over 40. 373 versus 375. Okay, I'd say we've pretty much peaked. So now we have 5,800 packed shells, 204 total pellets, or 100,000 explosive damage and a material efficiency of 375. And it costs 14,000 resource. So we will do the same with the three-dimensional Tetris design. Man, it was already so much cheaper in comparison. So we'll just instantly up it to 2,000 millimeters. Oh, it's already got gauge increases internally. I completely forgot about that. So I don't have to do too much. Just like so. 365. So it is already more material efficient. We haven't even done anything to it. So you could just leave it at that. You could just say, oh, okay. So right now it is cheaper. Basically the same cost in effect. It has more pellets. It has a similar firepower because of its reload time. Because it reloads in literally almost half the amount of time. And you could say that works. This is if you just want to do pure barrage damage. But we'll go all the way and get it as efficient as we possibly can. So 365 is what we started off with. I meant to press N, but I pressed B. So we'll replace the packers, or the pellets that have 4 connections first. 335. Replace the ones on the top. 318. 309. That's pretty nice. What's our reload time? 31.5 seconds. We still got a lot of room to play with. So now we're down to 306, and now 304.7. That was not much of a difference. Reload time is 38 seconds. I'd say we're pretty much done. So, looking at the stats of this turret, we have packed 5,900 pellets, which is more than the original design. Takes 38 seconds to reload, which is 4 seconds longer. Firepower is pretty comparable. Very little difference there. And the overall damage is very similar. So the only thing to look at is the cost difference. 14,000 versus the base 10,400. On to the 9x9. This is completely understating how long I took to build this. I started with... I don't know what hours I started at. All I know is I mathed it out, and yeah, I basically had been messing around with cram cannons for almost 150 hours. Admittedly, the first 100 hours, I did nothing. I was just exploding things. Okay, 9x9 design. I'll set this into segments in the video, so that should make it easy. As I said before, on top of the cram connectors, just place a 3-long section like so, building it across, like that. Oh, almost forgot the last one. Right, and you can use prefabs in this portion of one. If you're building larger turrets, you can start using prefabs because it makes it a little easier. So all you do is you drop the length to 2 and the width to 3, and you put a payload compactor in this area. And you can just copy this, and whenever you see like a T intersection like this, you can just paste it in. Like so. Like that. And we can do it going backwards as well if we want. But I think we can get a little more efficiency if we do this. So just like so. Okay. Now fill in the remaining spaces with payload compactors. The areas that we didn't get, we pretty much got everything. And then the final bit, which is just the gauge increases. Wonderful. And that is done. 7x7. Almost completely optimal 3-dimensional cram cannon. Oh shoot, this is a 9x9. Whoops. Okay, stacking it up. So, deleting that, and then placing down the edges. That, and then just connecting it all up. Okay. Put down our cram cannon firing piece. So here we go. 30,000 material cost, almost 2,000 material per firepower, and a firepower of 15.8 just on the base 2-dimensional without any editing. And just building the 3-dimensional cram, we have almost 4 times the amount of firepower, 3.5 times the amount of firepower. It costs 66% of the 2-dimensional cram and has a crazy much higher material per firepower. So if it's not already at 2,000 millimeters, we can just quickly add the extra gauge increases. That nets us even more material per firepower and even more pellets packed. Right, and we will begin the process of increasing the efficiency. So all these 4 connection packers, we will switch them out for payload compactors. 331 of material per firepower, 317, 308. Wow, this is nice. And then we can start now that we've changed all the 4 connections. If you want to, we can start editing the 5 connection pellets. So we're starting at 308, 304.8. 302.4, and what is the reload time? Oh, we're at 30 seconds. Oh my goodness. 308. 300. Now that is a nice number. That is a very, very... Ooh, we go a little bit under, but I won't do that. Just don't want to take too much. You know what I'm saying? There we go. Now let's increase the efficiency of the 2x2. Oh, what the heck, 2x2? The two-dimensional cram cannon Tetris. 1, 2, 1, 2, 1, 2, and a final 2 right at the back. Okay. Increasing the gauge took us from almost 2,000 down to 1,100, and now we have to replace all of these 3 connections. I'm pretty sure probably I'll have to replace all of them. So just the ones on the front and sides of one side, because I didn't mirror it. We were at 1,100. Now we are down to 409. 378. Okay, what is the reload time? 223. We do have room to play. 370. 366, and we'll see what replacing another one does. 364.8. Okay, that wasn't a lot. 363.4. Okay, we're getting down to only changing one, so I'd say that's pretty much close to the limit. So this was the two-dimensional stacking. Being more dense has a higher firepower. So the two-dimensional cram, 150,000 explosive damage, 9,200 pellets packed, and a reload time of 31 seconds. 63 firepower. The 3D cram has 34 reload time, same amount of damage. Pretty much the same amount of damage, just because there's only a difference of 200 pellets packed. 34 seconds versus 31 seconds reload time, basically the same. And 300 material per firepower. Now, you can't argue with that. Isn't that what we've all been waiting for? Oh wait, what's the material cost difference? 23,000. Was that 20? Yeah, 22,000 versus 17,000. Very nice. So that's about a difference of 6,000 resource. Oh, can't argue with the 300 material per firepower. Awesome. And we will now do an 11 by 11. So 11 by 11 ends up being a little bit weirder than the other turrets, than the other designs. It always, especially when I had to build it in the turret space, it was always off to the side. I don't know why it was so hard to manage. So if it's not mirrored, it does make it a little harder, but it just takes a little longer to build up your turret. But luckily we can use the prefabs to make it fast. As I was doing before, placing over the connectors as 3 long little slug, little droop. 3, 1, 2, 3, 1, 2. And then we will do our little T intersection design. So, and what we can do then is drop down the width to 3 and the length to 2, and we take this and we copy it along. Like this. Like that. And then we can spin it around. We can do these areas, because we don't want to forget them. They're very important. Let me just delete that. Okay. And now to fill up the remaining portions. So you want to... Every single explosive pellet needs a connector. Otherwise you lose quite a lot of efficiency. Because you just have all these explosive pellets that you're just not connecting to. This and this, and I think we'll be done with our payload compactors. And for the remaining internal space, we can fill it with gauge increases. And since every slot basically has, you can basically connect to one of these cram connectors, or a gauge increaser will be able to connect to them, it'll make it nice and easy for us. There we are. And we take this design and we go all the way to 11. Take it all the way up to 11. Height by a little bit. Up, and then we just delete the top layer, so we're at 5. Okay, now I have to connect it up. And I think what I'll do is I'll just copy over this, which I could have been doing before, but I don't. I'll just copy this over. Nice. Cram, firing piece. We're already at 2000 millimeters. That's because there's so many gauge increases. But it does give it a bit of redundancy, so I don't think it's a bad thing. Okay, so raw stats, right before we even do anything. We have a firepower of 16.1 before we've changed the two-dimensional cram, before we've added gauge increases, and we have a firepower of 82.56 before we've increased the efficiency of the three-dimensional Tetris. So we will go to the two-dimensional Tetris first, taking it all the way up to 2000 millimeters. I wonder if that was it. Nice. Okay. And what is the efficiency at? 1500 material efficiency. Let's start replacing these pellets. Generally, you want to replace anything that is 3 connections or below on your design, because then you get a nice increase in firepower versus a nice drop in material cost. Down to 461. Yeah, oh, definitely the edges, man. We really want to remove those. What is the current cost? Oh, the material firepower, 422. 406. And I think we can actually start replacing internal explosive pellets now. What are we at? 406. Replacing all the ones in the front line gets us down to 392. Material per firepower, 387, 377, so that was a change of 10, and 374, and I think we're approaching the limit now. Reload time is pretty good still. Dang. 368. What was it before I changed that? 374. Ah, can I just replace the entire top layer with payload compactors? This is going to be a very strong turret. 366. Okay. And replacing that, this line goes to 363, basically. So, reload time of 30 seconds. I think that is a pretty good place to stop. Yeah, that barely did anything. Okay, this is a strong-ass turret. 30-second reload time and an explosive damage of 220,000. Damn. Let's edit the three-dimensional Tetris. Lots of firepower as well. So we will go through and replace the... First going through and replacing all the pellets with only 4 connections to them. And I think we can go through and change all the ones on the edges. What are we at the moment? 338. There we are, 316, and I think we have room to grow, to get better. Okay, we can still replace the 5 connection. Oh, we have a corner piece, so we only have 4 connections on that one pellet. 310. 305. 301. What is our reload time? 27 seconds. Okay, so we've replaced everything on the outside, which does make it a bit more less explosive. Now we can start replacing the internal explosive pellets. So we're currently at 301 efficiency and a reload time of 28 seconds. What is this one's reload time? 30 seconds. So we're trying to get to 30 seconds and see where that gets us. 300, and if this is not changing anything, this is not changing anything. The internal pellets aren't making it any better. Let's get it down to 300. Let's get it down to 300. Just for our sake. A little bit under 300. There we go. 298, and we're at a reload time of 31 seconds, which is pretty comparable to 30.82. Nice. And we're under 300 material per firepower. How wonderful. So, damage-wise, 10,000 explosive damage difference, 12,000 explosive damage difference, similar reload time, similar pellets packed, firepower, 10% difference, but there is a almost 25-30% difference in the material cost. I am spitballing these numbers, that might not be correct, but 27,000 versus 35,000. What an improvement. Thank goodness 3D design is possible. Okay, the final turret I think I might do. And then I'll do the 17 by 17 at the very end of the video. Or the final cannon I might do is the 13 by 13, just to show that the process scales up no matter how big your initial sort of slice that you start off with. Boy, I hope this isn't boring. A mirrorable design. Like that, and then we build it out, and then another 3, and then 1, 2, 3, 1, 2, and then 1, 2, 3, 1, 2, 3, and 1, 2, 3, 1, 2. Nice! Let's build a T intersection. So, and then we will do a little prefab that gets us to copy this. So we copy this, and we start pasting it everywhere. In every T intersection we can find. Whoops. Like this. And we just flip it around and just do that. I mean, you don't lose anything. Right, now the edges. Cleaning up the edges of the design. Like that. And then we add our compactors in the crucial zones. I'm going to point that in that direction so it's less OCD destroying. And we add gauge increases. The larger the turret, the more the gauge increases are just going to be taking up resource rather than sort of helping, which is a bit annoying. But I kind of reason that away by saying it is redundant. Like, it's giving lots of redundancy to the turret. And that sort of satisfies my brain, and I kind of just don't care after that. 13 by 13. That, and deleting the top layer, let us... Ooh, I can do what I did on the previous turret. Just go over here, copy this, go over here, and paste it. Wonderful. And we will add a firing piece. Oh, I should probably drop that a while ago. Yeah, okay. I kind of forgot that the cram cannons make a lot of noise. I'm sorry, up until now, if it has been annoying, I'll try and make sure that my voice is a lot louder, or I reduce the volume of the game. Okay. So, without doing anything, the material per firepower of the 3-dimensional Tetris is at 400, basically, and the 2-dimensional Tetris is at 3,800. That is quite a difference. Let us increase the efficiency of the 2-dimensional Tetris. There we go. So that is just with the shell diameter increased. Right down to 2,000. Twice as efficient. And then we start replacing the pellets with only 3 connections. Damn, I thought I wasn't recording. I just looked over to the left and I saw a 0 out of nowhere, but it was for another stat and it freaked me out. I'm like, no way. No way. Okay, what are we at the moment? 421 efficiency. So we've got to get into the bloody gubbins of the turret, right into the center, right into the meat, the flesh. 400 efficiency. Material per firepower. Down to 384. Whoops. 374. That was a lot of 368. 367. Almost. What did replacing all of those do? 362. Okay, so we're really approaching a plateau, but we still have a lot of reload time to play with, so we can actually just go through and change this entire top layer without worrying too much. 359.1. What was it before? 361. So we're sort of plateauing. We can't really do much more. Oh, man, you could go and really try and just keep on replacing them. But I don't think we need to do that. We're pretty much at the most efficient it's going to get. And we'll probably be harming its firepower if we go any further. 300,000 explosive damage! And a reload time of 31 seconds. Very nice. Let's see what we can do to the three-dimensional Tetris design. So we will start by replacing the 380 material efficiency. We'll start by replacing the pellets with only 4 connections. And then the ones on the bottom. What are we at now? 320 in terms of our material efficiency. Then replacing the pellets with 5 connections on the sides. 304. Time to go into the gubbins because I think we have more room to play with. What is our reload time at? 25 seconds. Yeah, we got tons of room. 300. And we're at 28 seconds. So 299. 29 seconds. 30 seconds, 31 seconds, that's pretty comparable, and we have a material per firepower of 297. There we go. So these ones especially have the same reload time. About a 10% difference in firepower, which seems to be the normal sort of trend going down. Each of these is about a 10% difference in firepower, but there is a higher difference in material, which seems to be quite nice. Total damage, 282,000 versus 306,000. Pretty similar. I mean, you won't really notice it. Both damage, like the amount of damage they're doing is strong enough to break heavy. So we should be fine. What is the material efficiency again? 297. And they said it couldn't be done. And they said it couldn't be done. Versus 359. Very nice. I hope that was a nice and easy method to do three-dimensional cram Tetris. On to the next part of the video. I will be doing it for turrets. So the thing is with turrets is the pattern that you use, or the portion of this pie that you pull out and place on the turret base does change depending on the size of the turret and also its sort of like where you're allocating it, whether it's centered or it's off center or it's not rotated, but you'll see whether it can be mirrored. So I'll start off with the 5x5s. And as before, we will add the cram connectors in, just like this. Then we will go and add the payload packers into the T intersections, as I call them. You can call them something else. Like that, and then the compactors, and then the gauge increases, which is nice that we can add so many on this little turret. Okay, and now dropping the size. We can copy this and up, and then delete the top layer. Then we can connect it all up. Like so. Now we will increase the efficiency of the 5x5 turret. Damn. What are we at the moment? 341. Nice. So we are now at 335. 333. 332. I think I'd stop there. So we're at a 1,800 millimeters diameter. And let's see if we can increase the efficiency with any payload packers. So at 332, adding one payload packer, 324. No, not even worth it. There we go. So just adding gauge increases to get our diameter to 1,800 was enough to max out the efficiency of this turret. Actually, let's see if we can get this any lower. We just add a little more. No, we can't. What about one? Please, just one. Just one measly. Okay, whatever. Sadly, we cannot. There we go. So for the 3D design, stacking it 2.5 times so you get to at least the dense packing layers are 5 tall, plus the gauge increases, we get to a material firepower of 332 for a 5x5 turret space. Awesome. Now on to the 7x7. So a 7x7 design ended up being one of the offset designs, but luckily with this method it still works. You just won't be able to mirror it, which makes the whole process a little faster. So we build one going in like so. And then we build a T intersection here. And then 2 packers can face inwards here. Both are connecting to a cram connector. And then here we can have another... Actually, if I replace, I can have this one facing outwards. Then we can put a gauge increaser in there. That. And then we have... There we are. Just like so. I'll rotate that one around, just so that this payload compactor won't be lonely with only one friend. And we can rotate this one around. So that we can have 2 connect here. Honestly, I think he'll just have to be lonely. I'm sorry. As I'm going through, I realize that it's not all going to work. There we go. So that's how easy it is for a 7x7 turret. There we go, and then we go up to a 5 layer height. Why did I do it like that? We connect it all up. Like this. We add our firing piece. And we're starting off with a material per firepower of 453 at 1,100 millimeters diameter. Did I only add 1 gauge increaser in this entire block? Maybe. Then we will simply increase the gauge until it is efficient. 406. 395. 388. Like that. 386. We're quickly approaching a stagnation. 383. Reload time 17 seconds. Oh, okay, no, we'll just take it all the way up to 2,000. There we go. And we have a 50,000 explosive damage, reload time of 20 seconds almost, and a material efficiency of 380. So that tells me that we might be able to switch out some of these explosive packers to make it more efficient. Because some of these only have 3 connections. And that is because of this turret layout. Oh, sorry, the 2-dimensional pattern was the most efficient in a turret space. Okay, 380, 357. Wow, this is really going down fast. What if I change all these? 338. Very nice. 334. Starting to stagnate. We'll replace the pellets down the bottom. 328.4. 325, what's our reload time? 32 seconds. I'd say I'll just replace this one, and then I'll be happy. 33.5 seconds. So, it does 80,000 explosive damage, reloads in 30 seconds, and has a material efficiency of 323. Very nice 7x7 turret. We'll compare it to the cannon. What does the cannon have? The cannon reloads, I could make more efficient. It's lower reload. Okay. So if you, in a square space, you can get a higher material efficiency versus the space in the turret. Because some of these explosive pellets, you can't connect on 2 or 3 external sides. Okay, a 9x9 turret. We will build this in the same way. And luckily, this is a design you can mirror, so it should be nice and quick to build. Like this. Ah, we have T intersections. So I should be able to just do this and then go P and bring the size down and the length down as well, and just copy paste these throughout the whole turret. Oh, that's quite nice. We can just do that. We can delete those ones off the side. Like this, and then that one has to go in that direction, and these 2 have to go inwards. Then we place the errant compactors and the gauge increases. And I should have probably showed off the patterns for the turrets, but I think that is a fun project for you to do at home, if you watched the previous video. So 9 and 9 and 2. Remove the mirror. And we'll bring the mirror back. This, and then this, and then we'll go and copy that through. Place down our firing piece. Damage of the turret is pretty good, but I think we can get better. We are down to 398 material efficiency. And I think if I just do this, we are down to 390. So that did increase it. So we can go all the way to 2,000 millimeters on this cannon. Let us change the cram connectors. The explosive pellets, and exchange them out for packets. So currently at 390.8 material efficiency. Material per firepower down to 336. And then I think we can replace all these packers that only have, all these pellets that only have 3 connections. 308. What is our... Okay, what does replacing one more do? Or 2 more? 306. Oh well. The reload time is already at 30 seconds, so I'd say I'd probably stop there. So we end up with 7,400 pellets packed, 304 pellets total, packing per second, and because of the diameter we get to a reload time of 30 seconds, and 130,000 explosive damage total, and a material firepower down to 308.7. So the 9x9 turret starts getting down to those optimum levels of efficiency that we wanted. Whereas when you have a square design, you start getting there at around a 7x7. So you can save a lot of resource, or you could place a lot more turrets on your boat. However, they will be static, but just without being a turret. Nice. And should I do the rest? Yeah, I'll do the rest. It's gonna be a slog, but if you're here for it, I'm happy. Thank you for sticking with me and this incredible building journey. I hope it's not boring. Okay, 11x11. Yeah, this one is weird. So the 11x11 pattern that I had to pull out was different. It wasn't as per normal. Like it wasn't the optimal one to pull out. Wasn't the exact one that I wanted. Oh, it just didn't fit. What am I doing? T intersections. Yeah, okay, it's going to be a bit different on this. I'm going to have to manually put this in. This. And then this. And then... I'm going as fast as I can. Inwards and then upwards. Okay, and then we will place in the compactors. There. And yes, I think that's it. Yes, I didn't just accidentally place any of these compactors in the wrong space, so I think I'm pretty good. Add the gauge increases. Sadly, there's not a lot of space for gauge increases in this design. There is this, however, which is really annoying, but I think I can stack gauge increases down the side of the turret once I build it, which might help. Yeah, it was a really weird trying to find the most efficient two-dimensional layout for an 11x11 turreted space. It really was weird. Okay, and then we can just place gauge increases all the way down. Very nice. Oh, it looks like a spaceship. Okay, we're already at 2,000 millimeters. Wonderful. 407 material efficiency. Let us start replacing some of these pellets that only have 3 connections. 369. Nice. 344. Wow, I'm having a stroke. Hold on. Oh, interesting. These payload packets don't have connections, so I'm going to have to just feed a cram connector line down here. That might very much increase our efficiency. But that means we're no longer at 2,000 millimeters, so we're going to have to add gauge increases. There we are. 339 material efficiency. $326. 314, and the reload time is still 26 seconds, so we've still got a lot of stuff to play with. A lot of reload time to play with. 311, and we're at 28 seconds. We are at now at 33, and we have a material per firepower of 304. I'd say that's pretty good. Nice. So for an 11 by 11 turret, it's a bit weirder than the others, but you can still get a pretty nice material per firepower. Okay. Now, for a 13 by 13 turret. Luckily, the rest of the designs, as they get larger, the difference between different layouts, whether it is a design that you can mirror versus one that you can't, whether or not you need to also delete corners off of it, the difference does get less. Like there's less of an impact on your overall efficiency. So we'll do the 13 by 13. Stack it inwards like this, then we'll go outwards and then inwards again. Oh wait, I just deleted that. And I suppose you could just turn the video off now and go in and play and do this yourself, because it's really the same process. It was just me. I just wanted to show that this entire design process it just works. It's scalable. This whole 3D stacking. It's not particularly complicated. It was hard to find it or sort of figure it out. Because I just got stuck doing the same thing over and over again rather than learning from my mistakes. But once I sort of figured it out, it worked. And there we are. Okay, now to fill the remaining spaces with payload compactors like this. And this. There's a space in there, and the rest with gauge increases. Oh, forgot a spot. There we are. Then we will expand. Okay, and we'll connect it up. Like this. Adding a firing piece. Currently looking pretty good. It is already at 2000 millimeters, so all we need to do is start replacing the explosive pellets to increase material per firepower. Down to 365. Down to 343. Down to 318. What is our reload time? 22 seconds. We can start replacing the core packers. What are we down to? 304. Reload time is 26 seconds. Down to 300. How nice. How wonderful. This is what I subscribe for. 299.8. What's the reload time? 30 seconds. And we're under 300 material efficiency. Perfect. Perfect. So we're doing 230,000 damage. Under 300 material per firepower. And we have a reload time of 31 seconds. So what is the 13 by 13... that's the 11 by 11. This is 13 by 13. Square design. Oh, so the explosive damage is 280,000 versus 230,000. So there's only a difference of 50,000, but at this point the explosive damage is enough to destroy heavy armor. Very nice. I should have been showing how effective these are at destroying stuff. Wait, where is it? Oh, I have a Crossbones that's been sitting there. Okay, the most I'm going to do is the 13 by 13, because I want to explode some stuff. I'm kind of done just building it. You get the gist. We gotta get the accuracy down. Get the accuracy down. There we go. Okay. And then we go this. We go. We up the barrel rotation speed. And we do this. And then we. These don't look at these barrels. I'm just messing around. I'm just messing around. Don't focus on me. We go, and then the last tiny little baby cannon. Okay. Let us rotate. Okay, wrong button. I need to get back in my seat. Over here. There we are. Rotate. Your time is coming, Crossbones. You will be destroyed. Like this. Very nice. Okay. 1, 2, 3, 4, 5. Oh, it's good I stopped. So we'll hook this up to 1. Find the turret at the base. Hook this one up to 2. Find the turret at the base. Hook this one up to 3. Find the turret at the base. Somewhere. Then we hook up this one up to 4. We find the turret all the way at the base. And it's probably already on 4, but we'll make sure. And then 5. There we are. So, number 1 should let us aim the smallest turret. Let's see how effective this is. This is a 3x3x5 turret placed in a turret well. Let's shoot this portion here, right on the side of the turret cap. Here comes the crank cannon. I forgot to put inertial fuses. Yup. Never forget your inertial fuses. They are so important. Thank you for the perfect timing. Fuse box. Oh my goodness, that was perfect. That was exactly what I wanted. Wait, why can't I build it? Oh, it's on a different turret. That was so perfect. Oh wait, I forgot. And it bounces off. There we go. And then, yeah. Okay, so using the first smallest turret again, we'll try again. It probably hasn't reloaded. Oh, it has. Thank you. Don't miss. Oh, the strengths of cram cannons. How wonderful. Maybe I need longer barrels. Okay, we'll just aim at the base there. What is the damage you'll do? Ooh, 35,000 explosive damage. Very superficial. Kind of starting to dig in. Did crack through these shields. And the shield is just... that's angled metal, which isn't too full of health. But it did some well. Good job, little cannon. Little tiny little baby... Little baby thing. Let's use a slightly larger cannon. I'm going to repair this vehicle just so that it knows that it's going to die. Alright, this is the 5x5 cannon in the turret well, in the turret space. Against one of the main cannons of the Crossbones, once the smoke clears, we can see decent damage. I didn't even see what the damage of the cannon was, but it is starting to actually seriously cripple. A well-placed hit from this size of cannon will start doing some serious damage. I just refilled the Crossbones cram cannons. I hope he's happy. Okay. A 7x7, and we'll fire at the same place. See what it does. See if it even hits. Hopefully it hits. You didn't see that. You didn't see that. We'll try again. Okay, well, I'm a bit lower. And a side hit. Lots of blocks. 204,000 damage. Okay, very interesting. So... the explosion radius is large enough to start breaking into the turret of the Crossbones. We'll shoot at the side, and we hope that it hits the cap of the turret this time. Oh, wonderful. Oh, yes. Smoke. Oh, look at that. Okay, any more forward? So already this barrel is gone, and then it's only one more surviving that's connected to the base. Awesome, and that's all you need to do. You just need to disconnect the firing pieces from the base of the turret. What is the Crossbones going to do? Nothing. It can't shoot back. Can I just... separate the cram cannons. Nice. Alright, what does the next size up do? The 9x9. No, this is the 11x11. 270,000 damage. How nice. How nice. Everything's gone. Everything's gone. Let's reload and see what it does to the turret cap. See if I'm lucky. Ooh, perfect. Perfect. Yeah. Comparable to the size below, actually, but that's just because of the amount of metal in here. It has completely taken out 2 of the cram cannon barrels. Very nice. It's probably unlikely to shoot directly at the cap of the cram cannon, but if you have a chance, it'll destroy it. Now for the final, the largest of our designs, which was the 13x13 turret that I have over here. This one here. This big boy. Firing. Here it comes. Don't miss. Don't do it. You're gonna make me look bad. What? What? Okay. Thanks, cram cannons. I love you. Just a longer barrel. That's all you need. You'll get there. Damn, that's a lot of confetti. Not a lot of stuff. So it's really the explosion radius that's really hampering us here. I could test it against something stronger. So we'll look here, turn around, X. We will spawn the Bulwark. Gotta spawn it. We're gonna fire at the main front turret, because that is quite a lot of armor to deal with. We'll see how strong our 13x13 turret is against that. Please hit. What? That was nowhere near. Please hit. There. Right there. Roundabout there. Somewhat near. Much more hopeful. Hey, that was pretty spot on. Completely crippling the turret head. Destroying all this heavy armor. And opening it up for us to inspect. What's happening down here? Inefficient three-dimensional cram Tetris? Okay. Okay, we'll finish it off just firing all of them. Screw it. The laser defense system will probably not win. Okay, wow. Oh my goodness, that one cram cannon said, I hate laser defense. Very nice, very nice. Very, very nice. So, that was it. I hope you enjoyed my long, drawn-out tutorial on three-dimensional crams. Or three-dimensional cram Tetris. It was supposed to be a quick video, but it ended up being a lot longer because of how long it takes to build. And, yeah, but enjoy. Enjoy almost perfect efficiency 3D Tetris. High explosive. Glorious high explosive. Thank you for watching, and good night. This is Yogurt signing out. Catch you later.